The measure of angle B is 2/5 pi radians. If the degree measure of angle B is x degrees, what is the value of x? Now, if you read this question, you think, what's a radian? Pay attention because radians are on this exam. Pi radians is an angle measure equivalent to 180 degrees. And so if we use that conversion, then the radians cancel, pi's cancel, 180 over 5 reduces to 36 over 1, and so we're left with 72 degrees. The circle above has center O. The length of arc ADC is 5 pi, and x is equal to 100. What is the length of arc ABC? Arc ADC must have a measure of 100 degrees to match the central angle, and so 100 degrees over 360 degrees reduces to 5/18. And so that means that the length of ADC, 5 pi, must be equal to 5/18 of the circumference, which gives us a circumference of 18 pi. Now, it's not a coincidence that 18 pi is an answer choice. I can't stress enough how important it is to read the math questions twice. What is the length of arc ABC, not the circumference? Arc ABC is 18 pi minus 5 pi, which is 13 pi. In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N, respectively, and the segments intersect at point M as shown. If the circumference of the circle is 96, what is the length of the minor arc LN? Because segments LM and NM are tangent to the circle, we must have right angles at L and N, and because the sum of the interior angles of a quadrilateral is 360 degrees, the measure of angle LON must be 120 degrees, which means the arc LN must also have a measure of 120 degrees. That's 1/3 of the circumference of the circle, which has a length of 96, and so the length of arc LN must be 32. In the figure above, the circle has center O and radius 10. If the length of arc AB is between 5 and 6, what is one possible integer value of x? This problem is going to knock a lot of people off their footing because a range of possible values are acceptable. And anytime you have a range of possible values, a good practice is to solve for the lower bound and the upper bound of the range. And so in this case, the radius is 10, which makes the circumference 20 pi. And the lower bound of this range will correspond to a value of 5 for the arc length of AB. So 5 over 20 pi means that arc AB is 7.96% of the circumference of the circle, and 7.96% of 360 is 28.6 degrees. So that's the lower bound of our range. That's the least that x can be. And so if we just swap out 5 for 6 in that calculation, we end up with 34.4 degrees as our upper bound. And so any integer value greater than 28.6 and less than 34.4 will work, and so I'll go with 30. Segments OA and OB are radii of the semicircle above. Arc AB has length 3 pi and OA is 5. What is the value of x? Since OA is a radius, the circumference of the full circle must be 10 pi, and so arc AB accounts for 3/10 of that full circumference. And so angle x must be 3/10 of the full 360 degrees, and so that comes out to 108. In the figure shown, angle AXB and angle AYB are inscribed in the circle. Which of the following statements is true? So angle AXB and angle AYB are both inscribed angles that intersect the arc AB, which means that each of them must have an angle measure equal to half of the measure of arc AB, and so they're equal to each other. To see more content like this, be sure to subscribe and check out my next video on trig functions on the digital SAT.